All right, so how's it going? We're going to go through 2.3 polynomial functions on the worksheets. So let's see here. We need to find all the zeros, state any multiplicity, and if the zero touches or crosses the axis. So first off, to find out if it touches or crosses the axis, if you know that the multiplicity is even, it will touch off the axis, and then if it is an odd number for the multiplicity, it will cross through the axis. So what that means is that if it's even at that zero, in other words at that x-intercept, the graph will kind of like just barely get to the x-intercept and then turn back around like that. Whereas if it crosses through the axis, then at that x-intercept, your polynomial will go directly through the intercept and keep going. Okay, so it'll kind of look like that for odd or even multiplicities. So now to find the multiplicities and the zeros, let's start with the zeros part of it. So for any zero, when it says find all zeros, all you have to do is, if it's factored like all four of these problems, all you need to do is take each of the individual factors and set them equal to 0. So like the first one that I have here, 2x plus 1. If I set that equal to 0 and solve, I subtract 1 from both sides. So I get 2x is equal to negative 1, then divide by 2. X is equal to negative a half. That's one of my zeros right there. All right, now let's find our next zero. So if I have x minus 1 equals 0 and I solve it, if I add 1 to both sides, I get x equals 1. That's my other zero. Now for the multiplicity. So the multiplicity, when it's factored, is just going to be the power on each of the factors. If there's not one that's listed, it's always just 1, okay? So that means that when I have this 0 of negative 1 half from this factor, it has a power of 1, so its multiplicity is going to be 1. For this factor, since I have a power of 2, when I have this 0 at x equals positive 1, that means that its multiplicity is going to be a positive 2. Now, remember what we said. If the multiplicity is an even number, then that means that it's going to be touching the axis like this. And then if it's an odd number, it's going to cross through the axis like this. So since we have an even multiplicity with 2, like an even number, 2, 4, 6, 8, 10, since 2 is an even number, then that means that it's going to touch off of the axis like this. And since this multiplicity is 1, it's going to be an odd number, so it's going to cross directly through the axis. So just write C for that. So that's how we do number 1. Same thing for number 3. We underline each of the factors. So x is a factor, 2x plus 1 is a factor, and x minus 1 is a factor. We set each of these equal to 0 and solve. This is an easy one. If x is equal to 0, it's already solved. So this is one of my zeros, x equals 0. The next one that I have is 2x plus 1 equals 0. So I solve that, subtract 1, divide by 2, and I get x equals negative a half again. Same thing as the previous one that we just had. And then if we have x minus 1, set it equal to 0 and solve, x is going to be equal to 1 again. So here are all of our zeros. Now let's list off the multiplicities. I don't see any powers here, so each one of them is going to have a power of 1, and that means it's each going to have a multiplicity of 1. And since 1 is an odd number, then that means every one of them is going to cross directly through the axis. So it'll look like this on the graph for each one of those when we graph it out eventually. Okay, moving on to describing the end behavior. So the end behavior is based off of kind of like a table. We need to figure out the degree of the polynomial, which is the biggest power of any of the terms in the polynomial. And then also we need to look at the sign on the lead coefficient. So if the degree is even or odd, we need to take note of that. And we also need to tell if the sign on the lead coefficient is positive or negative. So if we do that, then we split it up into 4 different columns, okay? If it's an even degree and a positive lead coefficient, then the end behavior is up on the left and up on the right. If it's an even degree and negative lead coefficient, it's pointing down on the left, down on the right. If it's an odd degree and a positive lead coefficient, it points down on the left and then up on the right. And then if it's an odd degree and a negative lead coefficient, it points up on the left and down on the right. Okay, so these are all the 4 different options that we can have for number 5, 6, 7, and 8. So here's how we can check it. We first want to look at the degree, and then once we find the degree, we want to tell if the lead coefficient is positive or negative. And that's going to be the same for all of these. That's how we get the information that we need for the end behavior. So the degree is always the biggest power and on any of the exponents. So for any of these exponents here, the biggest power is 4, so that's our degree, 4. And then on that term that had the 4 on it, what's its sign? Is it positive or negative? In this case, it's a positive, x to the fourth, so it's a positive number. So since the degree is an even number, 4 is an even number, I mean it's going to be one of these two, and then since it's a positive lead coefficient, that means that it's going to be even and positive, which means it's going to be up and up on the left, up on the right. And end behavior just tells you what the graph looks like at its extremes on the left and on the right. Okay, next, number 7, the degree on this, the biggest power is 3, so that's our degree, 3. And then on that term, it has another positive lead coefficient. So if the degree is 3, that's an odd number. And then if it's a positive lead coefficient, positive and odd means that it points down on the left-hand side and then up on the right-hand side. So that's how our graph is roughly going to look on its extremes as well. So that's number 5 and number 7, end behavior, and then also finding zeros, multiplicity, and if it touches or crosses. Next, state the minimum number of turns of the graph, and then sketch the graph using a graphing calculator and approximate each real 0 to the nearest tenth. Approximate the relative minimum or maximum for each to the nearest tenth. Okay, so for these two, we're going to use our calculators, and then for this, we're going to use our calculators. The only thing that we can't is the turns on the graph, but the turns are really easy. It's just, if you know the degree, if you take away 1 from it, then that gives you the number of turns. That's a formula you can always use. So, and it's real easy to use. The number of turns in this case, for this problem number 9, since the degree is 4, if we take away 1 from that, 4 minus 1 is 3. So there are 3 turns. Okay, turns just mean where it goes from increasing to decreasing on a graph, and we'll see that here in a little bit when we graph it on out. All right, so now for some next level graphing on our graphing calculator. So we go to y equals, and we type in that expression, so x to the 4th power minus x to the 2nd power plus x plus 4. Now we're going to graph it out. Okay, there it is. Now I'm even going to make it so that the graph, so notice that these all go to like 10 to the right, 10 to the left, 10 up, and 10 down. All these ones go to 8, so I'm going to use my calculator and change it to 8 instead. So I hit the window button, and the x minimum and x maximum tell you how far to the left and right the graph goes. So it goes to the left to -8, and then it goes to the right by 8. And then this SCL means scale, so how much does it go up by each time? So each line goes up by 1, so I keep it as 1. Y minimum, that's up and down, the y values, so that's going to be -8 for the minimum, and then 8 for the maximum, and it goes up and down by 1 also. So then I hit graph, and there's my new adjusted graph. There we go. Okay, so it looks like we get to that point right over there. That y-intercept is going to be at 0, and then 1, 2, 3, 4. So at 0, 4, I'm going to make a little point right there. That's my x-intercept. And then from there, it looks like I have a minimum value right there. I don't know what exactly it is, but it kind of looks like it's going to be about -1, 3. So just to estimate, -1, 3 would be like right there. So it looks like the graph kind of goes down to that point, and then it kind of just goes up like that. And then for this one, it kind of like stays even, and then it goes up like that. So that's my graph at that particular value. And then let's find the relative minimums and maximums. The only minimum that we're going to have is that value. So here's how you can find a really approximate value on your calculator. So the minimum and maximum function on your calculator is found by hitting the second button and then the trace button, because it says the CALC right here, calculation things. So we hit second and then trace. And then if we're looking for the minimum here, so it's the low point on there, so it's a minimum, we go to minimum on our calculator. So that's the third one. So now it asks you a series of questions on your calculator. It says left bound. So it's trying to narrow down where your minimum is. So this says, can you please go to the left of the minimum? So you use your calculator's cursor, the left and the right buttons, and you move a little bit to the left of it. And then when you're to the left of your minimum, hit hit enter. Okay. Now it says the right bound. So you go a little bit to the right of where your minimum is. I'm going to say like right there, okay? It's to the right of it, so it narrows it down to this area in our calculator. Now it says guess, so now your calculator is saying, hey, can you guess kind of where it is? And I'm going to say it's like right around there. I hit enter, and it gives me the actual minimum value. So the minimum value, I estimated it was -1, 3, and it's actually -0.88 for the x value, and then for the y value, it is 2.94. So that's the actual relative minimum. And then for relative maximums, there are none. So just write maximums and then none right there. And you're done with all of that stuff. So this is the first page of 2.3, and then I'll make another video for the second page. So continue on.